Elon Musk's idea of Hyperloop is a reinvented creation. It came from the history of American offices and banks, as they have used PTT, the old technique of Hyperloop, called pneumatic tube transportation, for transportation of drugs, mails, files, and disk drives, etc. As this is invented by William Wardock. This PTT propels cylindrical containers through a network of tubes by compressed air or by partial vacuum. Still, some banks are using this PTT transportation for their secret physical information packs to get rid of cyber attacks. This does not get into popularity due to heavy work and not much as fast as possible. These tunnels are vast network of tubes in the underground. As this makes us to limit our heights, we cannot redirect. A single tunnel is for single route. We can't use in intervals. These limitations are taken into account by Elon Musk and proposed it as Hyperloop. As the Californian government proposed a railway project from California to Los Angeles, as this takes lots of billions to construct and much more area to accommodate. The Hyperloop is the only one way which takes less space and less expensive and acquires high speeds. This is the latest technology which is constructed with two tunnels to and from motion from the San Francisco to California. These two tunnels are placed on pylons and stacked on pillars. These tunnels are embedded with solar plates, which makes energy for the transportation of Hyperloop capsules. As these Hyperloop capsules have to transfer pressure from one side of the tube to the other side. So they have to overcome the Cantor's limit, which is the limit of pressure transfer in tubes. This is a physics term for the hydrodynamics in tubes. The hyperpod or capsule which have to travel like a fluid inside the tube. So it attains 20 miles per hour with his linear inductive motors. When it attains that top speed of 20 miles per hour, it have to levitate. This levitation takes place by its inductive magnetic motors, which creates a magnetic field inside the tube, which makes this capsule to levitate and attains his miracle, that is frictionless transportation, which is the non-wear and tear transportation. The levitation of this pod makes it to achieve high speed of 700 miles per hour, with record breaking the latest bullet train maglev. So Hyperloop became the best idea for Californian government to implement for his rail project.
Germany, a team of students is working on a new transportation concept called Hyperloop.
I do think that we are changing the future of mobility.
It's definitely very crazy. It's also a lot of fun and a lot of hard work.
Key partner is Panasonic, an innovation driver of sustainable networked mobility concepts.
University of Munich and Panasonic both enjoy a rich history in electronics. At the same time, this university is known as a leader for future sciences and very successful in developing advanced mobility concepts such as the Hyperloop.
With its strong expertise, Panasonic decided to support the students in entering a worldwide Hyperloop competition.
Panasonic Industry did provide the Hyperloop project with components for our pod, and also with the knowledge transfer from Panasonic. sensor from Panasonic Industry determines the position of the pod inside of the tube. To achieve this, the laser reads several markings within the tube while it accelerates to a maximum speed of 600 kilometers per hour. The specific design challenge for us is not only that the laser reads the marks, but also that this information is processed at a fast rate. The detection of these marks had the strictest timing requirements of any of our tasks. The 10 centimeter wide marks pass in front of the laser sensor in 600 microseconds at a relative speed of 166 meters per second, which demands a 1.6 kilohertz minimum sampling rate. Panasonic Industries laser sensors are a great fit for this challenge, as we can rely on their robustness against disturbance and environmental influences. Plus, they are very small and lightweight, which are a key criteria for us.
It takes about 10 months to build a Hyperloop pod.
As this event is a students' competition, I expect to learn a lot. My motivation is not really winning the competition, but to learn as much as possible about computer science, about electronics, and get familiar with the industry also, as we have contacts to the industry like Panasonic.
The Hyperloop is not a pipe dream. Already this year, you will see several big announcements, such as Virgin's Hyperloop One.
At supersonic speeds, the Hyperloop will connect cities like Munich and Berlin within 30 minutes.
Panasonic has helped us a lot with different components, choose the right ones. For the controlling of our subsystems, we picked Panasonic's relay, which convinced us due to its high density mounting, low operating power, and due to its small casing.
Panasonic wants to change the future of transportation, and so do leading mobility companies worldwide by pushing the Hyperloop transportation concept. The idea behind it is simple: a floating train being propelled at high speed in a vacuum tube.
Usually to levitate, you can use either air bearings, basically blasting air to levitate, like air hockey tables, or you can use magnets. When you do that, you create levitation. Linear induction motors then propel the pod along the tube. You get pushed at high speed, and you will stay at high speed a long time, because you don't have any friction from the ground, and you are in a vacuum. For our design, we have decided on a third way, using wheels for acceleration until lift-off speed is reached or needs to be braked. Using an electric motor guarantees us the best possible acceleration. Based on that, a cooperation with Panasonic Industry was a logical and necessary step for us.
Within the electronic battery control systems for charging and cell balancing, we are looking for any advantages that can be gained in the critical areas of stability and reliability, both vital factors in securing a pole position for our Hyperloop pod. Panasonic supported our Hyperloop by providing thick film chip resistance.
While the Hyperloop idea may be simple, the engineering is not. In the summer of 2018, the third global Hyperloop pod competition took place at the SpaceX Center in California, USA.
It is going to be my first time going to the USA to participate in a competition.
Los Angeles, California. The global contest takes place in a 1 mile long test tube.
We do have high hopes. There's lots of things that can go wrong, so we are trying to be careful.
Elon Musk, founder of Tesla and SpaceX, conceived the idea of the Hyperloop competition in 2013.
I really think that we have a very good team and that we can go far. And I think it's time to test our pod and see the work that we have done.
The team is competing against other engineering students from around the world.
The big challenge now is to have nothing go wrong.
At this point, we are going to hand it over to Team VAR for their final pre-race countdown.
projects Panasonic is working on for a sustainable mobility future.
We look forward to many additional wins of the Technical University of Munich's Hyperloop project supported by our technologies.
For more technical information on Hyperloop, we will upload a part 2 video only on technical part. As my accent is not so good, I will improve it later. Thumbs up if you liked it. Subscribe if you